Hi students, welcome to my teacher channel. In this video, we are going to solve the problems given in exercise 1.1 of real numbers chapter from 9th class mathematics. The sixth question is like this. Express the following rational numbers in decimal form. So here are some rational numbers and we have to express them in decimal form by simple division. Now, let's see the first one is like this, 242 by 1000. Children, here it's pretty easy. Without division, convert this into a decimal like this. 242 by 1000 is nothing but, since in the denominator 1000 is there, a 10 multiple. Now, let me write the numerator as it is. Now, how many digits, how many zeros are there in the denominator? Let us see. 1, 2, 3. Now, in this number, leave 3 places. 1, 2, 3 from right side. And then put decimal. Okay. Now, 242 by 1000 is nothing but 0.242. So, pretty simple. That's it. No need of doing a division. Right. Now let's see the second one. 354 by 500. Now this can be written as, let me write 354 by 500. Since 2 zeros are there in the denominator, cancel them and before 2 places, keep the decimal point, 3.54. Now with 5, you divide this. With 5, let me divide 3.54. Now, since 3.3 doesn't go in 5 table, let me take 0 point. Now it becomes 35. 35. 5 sevens are 35. The difference is 0. Let me take 4. Will it go in 5 table? No. So let me put 0 here and 0 here. Now 5 8s are 40. Simple. So 354 by 500 is nothing but 0.708. The third one, pretty simple, 2 by 5. So divide 2 by 5 like this. 2 doesn't go, so let me take 0 point. So 0 will come. 5 4s are 20. Difference is 0. So 2 by 5 is nothing but 0.4. Yeah. Now fourth one. With 4 divide 115. Now 4 2s are 8. 11 minus 8 is nothing but 3 and 5 is carried here. Right. Now 4 8s are 32 and the difference is 3. Let me put point and take 0. Now 4 sevens are 28. 2 is the remainder. Then point is there, so you can take 0. 4 5s are 20. So 115 by 4 is nothing but 28.75. So if you keenly observe these 4 results, and each fraction is converted into a terminating decimal. All these are terminating decimals. So all the terminating decimals can be expressed in P by Q form in reverse and they are rational. The second set of rational numbers are like this and we need to convert them into decimal form. Now let's start with the first one. 2 by 3. Right. So by 3 we need to divide 2. Okay, 2 doesn't go in 3 table, so what we'll do? 0 point. So it becomes 0. 3 6 are 18. Since decimal point, the difference between 20 and 18 is 2. Since the decimal point is there, we can take 0. Again 3 6 are 18. Difference is 2. Decimal is there, so take 0. 3 6 are 18. So 2, that means it is repeating. So 2 by 3 is nothing but 0.666 so on, which is also written as 0.6 bar. So if you put bar on a digit, that means it is recurring decimal. So it is a recurring, non-terminating and a recurring decimal. We'll go with the second one. Okay. Now, minus 25 by 36. That means we need to divide 25, minus 25 with 36. So, with 36, let me divide 25. Since 36 doesn't, 25 doesn't go in 36, let me take decimal point, 0 point. That means you can add zeros. So, now, 36 6 are, yeah, 36 6 are, 6 6 are 36, 6 3 is 18 plus 3 21. So which is near to 250? That means 36 6 are 216, 215 216. The difference is 34. Since decimal point is there, a 0 will be added. Now 36 9s are, 9 6 are 54, 9 3s are 27 plus 5 is nothing but 32. So 324. 36 9s are 324 and the difference is 10 minus 4 is 6 and 3 minus 2 is 1. Since decimal is there, you can take 0. Okay. Now 160. 36 4s are 4 6 are 24, 4 3 is 12 plus 2, 14, 144, which is near to this. So 36 4s are 144 and the difference is 160 minus 144. Yeah, 10 minus 4 is 6 and 5 minus 4 is 1. Again 16 came and decimal point is there, so you can take 0, so 160. Again you can take 36 4s are 144 and the difference is 16. Take 0, 36 4s are. So that means 4 is repeating here. So minus 25 by 36 can be written as 0.6944 and so on, or 0.69. The 4 is repeating, so you put bar over 4. With 7 divided 22. 7 3s are 21. 1 is the difference. Take decimal point. So 0 will be added. 7 1s are 7. Difference is 3. Decimal point is there, so 0 is added. 7 4s are 28. 2 is there, so 0 is added. Now 7 2s are 14 and then 6 is the difference. Take 0. 7 8s are 56. 60 and 56. Difference is 4. 0. Now 7 5s are 35. Difference is 5. 0 is added. 7 7s are 49. Difference is 1 and 0 is added. 10. I think 10 already came somewhere. Yes. So that means from here again the steps will be repeating. So after this 7 1s are. So 1 is repeating here. 7. So it repeats. So from 1 to this part, this whole part of the decimal is repeating. So 22 by 7 can be written as 3.142857. So over 142857 you put bar. That means that is a recurring part of the decimal. Now the fourth one is 11 by 9. That means with 9 we have to divide 11. 9 1s are 9. 11 minus 9 is 2. Take decimal point 0 and then 9 2s are 18. 2 again 0. and 9 2s are 18. So here 2, 2, 2, it is repeating. That means I can write 11 by 9 as 1.222, so on R 1.2 bar. Seventh question is like this. Express the following decimals in p by q form where q is not equal to 0 and pq are integers. So here some terminating decimals are given and we need to convert them into p by q form. Okay, so the first one is like this, 0.36. Now 0.36 can be written as 0.36 by 1. Here after the decimal point, two digits are there. So two digits are there, that means we have to multiply numerator and denominator with 10 power 2. 10 power 2 is nothing but 100. So let me multiply here 0.36 by 1 into 100 by 100. So when you multiply with 100, the point in 100 two places are there. So the point moves two places right side. 1, 2. That means it comes after 6. So 36. 1 into 100, 100. 36 by 100. 2 50s are 100 and 2 18s are 36. I think it can be further simplified. 2 25s are and 2 9s are. So 9 by 25 is the simplest form of the fraction. So 0.36 is nothing but 9 by 24. Therefore 0.36 is equal to 9 by 25. Now we'll move to the second one. 15.4 can be written as 15.4 by 1. See children, here how many places are there? How many digits are there after the decimal point? Yes, after the decimal point, one digit is there. So 10 power 1, that means 10. With 10, we have to multiply both numerator and denominator. 15.4 by 1 into 10 by 10. So since we are multiplying with 10, the decimal point moves one place towards right side. So after 4 the point comes. So 154 by 1 tens are 10. Or simply write all the digits 154 by in place of 0.1 and after that one place is there, so 10. Done. Now simplify it. 2 5s are 10 and 2 7s are 14, 1 left and 14, 2 7s are. So it becomes 77 by 5. Therefore 15.4 can be written as 77 by 5. Now third one, 10.25 can be written as 10.25 by 1. Now after the point, two places are there. So 10 power 2, 10 power 2 is nothing but 100. Multiply both numerator and denominator with 100. 10.25 by 1 into 100 by 100. And now, since we are multiplying with 100, the decimal point moves two places towards right side. 1, 2 means after 5 it comes. So 1025 it becomes by 100 the 100. Now let's simplify this one. 5 20s are 100. Now 5 2s are 10. 2 doesn't go, 0. 5 5s are 25. I think further it can be simplified. 5 4s are and 5 4s are 25 1s are. So this can be written as 41 by 4. Therefore 10.25 is equal to 41 by 4. Alright, now we'll go with fourth one, 3.25. Write 3.25 as 3.25 by 1. Now after the point, two places are there, two places. So 10 power 2 means 100. Multiply with 100, both the numerator and denominator. 3.25 by 1 into 100 and by 100. So point moves two places, 1, 2. After 5 it comes. So 325 by 100 is a 100. Now 520 is a 100 and 5 6 are 32 left 25. 5 5 are 25. Further it can be simplified. 5 4 are 20 and now 5 1s are 5, 15, 5 3s are. So it can be written as 13 by 4. Therefore 3.25 is nothing but 13.4. So like this, we can convert the terminating decimals into P by Q form in this way. Eighth question is like this. Express each of the following decimal numbers in P by Q form. And the first one is 0.5 bar. See, in this bit, they have given the non-terminating recurring decimals and we have to convert them into P by Q form. Okay, now we'll start with the first one. 0.5 bar is the first one. How are we going to do this one? Simple. First, let me assume that the given decimal is x. X is equal to 0.5 bar, which means x is equal to 0.555 so on. That means 5 is repeating. Okay, next, here how many digits are repeating, or how many digits have bar upon them? Yes, one digit is having bar, so the periodicity is 1. If periodicity is 1, we have to multiply the given number with 10 power 1, means 10. So let me multiply with 10. 10 into x is equal to, on both sides, 10 into 0.555 and so on. That is nothing but 10 into x is nothing but 10x, which is equal to, when you multiply with 10, the decimal point moves one place right side. So it moves here, one place. That means after the first 5. 5.555 so on. Okay. Now from this 10x, let me subtract 1x. So minus x. Minus, what is the x value? 0.555 so on. Now subtract. 10x minus 1x is nothing but 9x. Here 5 minus 5 0, 5 minus 5 0, 5 minus 0 is 5. So 9x is equal to 5. Then only 1x is equal to into 9. If we are transposed to right side, into 9, other side by 9. So it becomes 5 by 9. So x value is 5 by 9. X is actually 0.5 bar. So 0.5 bar is nothing but 5 by 9. Therefore 0.5 bar is nothing but 5 by 9. The second one is 3.8 bar. Okay. Now, what is the first step? Yes. Let x is equal to 3.8 bar, which is nothing but x is equal to 3.888 and so on. Now, what is next step? We have to see the periodicity, means how many digits are repeating, or how many digits have a bar upon it. Yes, here just one digit is having a bar upon it, so the periodicity is 1. That means we have to multiply by 10 power 1. 10 power 1 nothing but 10. So let me multiply x with 10. So 10 into x is equal to 10 into 3.888 and so on. So 10 into x is nothing but 10x, which is equal to 10 into, so point moves one place towards right side. So after this 8, point will come, means 3 8 then point, 38.888 and so on. Now from this 10x, let me subtract 1x. So minus, what is 1x? 3.88 and so on. 8 minus 8, 0. 8 minus 8, 0. 38 minus 3 is nothing but 35. And 10x minus 1x is 9x. Yes, 9x is equal to 35. I want only one x. X is equal to into 9. Other side by 9. 35 by 9. Therefore, 3.8 bar can be expressed as 35 by 9. The third question is 0.36 bar. Here two digits are repeating, 36 and 36. Okay. So first let me write, let x is equal to 0.36 bar, which is nothing but x is equal to 0.363636 and so on. Okay. Now here how many digits are having bar upon them? Or what is the periodicity? Here 1, 2. Two digits are having bar, means two digits are repeating. Since two digits are repeating, so the periodicity is 2. So we have to multiply by 10 power 2. 10 power 2 is nothing but 100. So we have to multiply by 100. So if I multiply by 100, 100 into x is equal to here 100 into 0.3636 and 36 so on. When we are multiplying with 100, the point moves two places right side. 1, 2. So after this, the point moves. So 100 into x is 100x is equal to here the point is moving, no? So after 36, 36.3636 and so on. From this 100x, let me subtract 1x minus x. So what is x minus 0.3636 so on. Now 6 minus 6 0, 3 minus 3 0, 6 minus 6 0, 3 minus 3 0. 36 minus 0 is 36. Okay. And 100x minus 1x is nothing but 99x, implies only 1x is equal to 36 into 99 other side by 99. This can be simplified. See here, 9 ones are 9, 9 ones are 9 and 9 fours are 36. That implies x is equal to 4 by 11. Therefore, what is x? 0.36 bar is equal to 4 by 11. In this bit, the fourth one is 3.127 bar. So 7 is having bar. So the first step here is let x is equal to 3.127 bar. See, you can write it as x is equal to 3.127 and 7 so on. Children, you have to be very careful to write the repeating part of the decimal. Which digits are having bar, those digits only has to be repeated. Here only 7 is having bar, that means 7 has to be repeated. Okay, next. And the next step is how many digits are having bar? Just one digit is having bar, means periodicity is 1. If periodicity is 1, we have to multiply with 10 power 1. 10 power 1 is nothing but 10. So multiply with 10. 10 into x is equal to 10 into 3.12777 so on. Now 10 into x is nothing but 10x, which is equal to 10 into this decimal. When you are multiplying with 10, the decimal point will move one place towards the right side, means after 1. Okay, 31.277 so on. From this 10x, let me subtract 1x. So minus x value is 3.1277 so on. 7 minus 7, 0. 7 minus 2, 5. 2 minus 1, 1. 31 minus 3, 28. Okay. 10x minus 1x, 9x, which implies only one x is equal to 28.15 into 9 other side by 9. Now since still decimal point is there, so this can also be written as x is equal to, remove the decimal point, okay, by 9. After the decimal point there are two places. That means if I remove the decimal point in the denominator, we get two zeros. Or simply multiply both numerator and denominator by 100. Okay. Now this has to be simplified. 5 ones are 5. Out of 9, 5 gone. So 4, 4 0 40. 5 8s are 40. 5 zeros are 0. Now 5 5s are 25. Out of 28, 25 gone. 3 left. 3 1 31. 5 6 are 30. 31 30. 1 left. 1 5 15. 5 3s are 15. So here x is 563 by 180. Therefore, what is x? X is this one. 3.127 bar can be written as 563 by 180. So the ninth question is like this. Without actually dividing, find which of the following are terminating decimal. So here we got 4 fractions, and the trick is we should not divide, but we have to say whether that is a terminating decimal or not. And how are we going to do this? Simple. If the denominator of the fraction is split into prime factors and that is in the form of 2 power m into 5 power n, then such fractions can be expressed as terminating decimals. Let me tell you once again. The prime factors of the denominator are in the form of 2 power m into 5 power n. Then such fractions are terminating decimals. If they are not in that form, then they are not terminating. Okay? So that's simple. The first one is like this. 3 by 25. Now the denominator is 25. Okay. Now what is the prime factorization for this? 25. 5 5s are 25. That means 25 can be expressed as 5 square, isn't it? So since 2 is not there, you can write 2 power 0 into 5 power 2. Now here is the denominator. 2 power 0 is nothing but 1. 1 into 5 square is 25. 25 is 25. So now the denominator is in the form of 2 power m into 5 power n. So it is a terminating decimal. Let me write the same thing. Here denominator is in the form 2 power m into 5 power n, that is 2 power 0 into 5 square. Therefore 3 by 25 is terminating decimal. Okay, now let's go for the second one. 11 by 18. See, the denominator is 18 here, and the prime factorization for 18 is 2 9s are and 3 3s are 9. So 18 can be written as 2 power 1 into how many 3s? So 3 into 3, that means 3 square. See, is this in the form of 2 power m into 5 power n? No. Here we got 3 square. So here denominator is not in the form 2 power m into 5 power n. Therefore, so since it is not in that form 2 power m into 5 power n, therefore 11 by 18 is not a terminating decimal. 11 by 18 is not a terminating decimal. Okay. Now the third one. Denominator is 20 and prime factorization for 20 is 2 tens are 2 fives are. So 20 can be written as 2 into 2, 2 square into 5 power 1. Now is this in the form of 2 power m into 5 power n? Yes. So since denominator is in the form 2 power m into 5 power n, the given fraction 13 by 20 is terminating decimal. What is this? Terminating decimal. Okay. The last fraction is like this, 41 by 42. Now the denominator 42. Let me split that into prime factorization. So 2 2s are 4, 2 1s are 2. And then 3 7s are 21. Now 42 can be written as 2 into 3 into 7. Now is this in the form of 2 power m into 5 power n? No. So since 3 and 7 extra are there, it is not in that form, therefore it is not a terminating decimal. So let me write the same thing. Since the denominator is not in the form of 2 power m into 5 power n, 41 by 42 is not a terminating decimal. Okay, so like this we can find without actually dividing whether the fraction can be expressed as terminating decimal or not.